Okay, this Pinacol utilization, this different reaction I have mentioned, I have explained one by one. These are very important for exam point of view for plus 2 student. Like you can see HS exam, even IIT, JEE, NEET, such transformation practice for such transformation is very essential. Another thing, this is another reminder, means a recapitulation of your knowledge about this reaction. So many reaction will recapitulate during this discussion. Okay, so let's start. Actually, as the headline you can see, use of Pinacol. So we are going to utilize this Pinacol. So Pinacol is 1,2-di-alcohol, as I told. So what alcohol can do? Alcohol can undergo dehydration. And second point is that this is a tertiary alcohol. Okay, if you use aldehyde for the preparation, then it's a secondary alcohol. So it is expected that alcohol, since it is alcohol, so it can undergo dehydration in presence of base. And actually this is dehydration reaction. Dehydration reaction. So which are dehydration? Here you can see this is dehydration, this is dehydration, and this is dehydration. But here dehydration reaction plus rearrangement. I will discuss about this rearrangement in the next video. This is called Pinacol rearrangement. It's a very important topic. Okay. So let's start the discussion. So if we use HBr and distill, it produces this transalkene as a major product, and minor product is Pinacol. I will explain. You can see if we heat in presence of alumina, this produces this, and actually transalkene. So you may think that why it is trans, you could have been written it cis, but one thing is that there is a dipole moment operating in the opposite direction. If you write cis, here total dipole moment is 0, but if you write cis, then there will be a neat dipole moment, means this direction. So that dipole moment more means stabilization is less. So consequently, it will prefer to remain in trans direction. Another thing, such type of dienes are very important for Diels-Alder reaction. Diels I will explain later in separate video, but this is a very important. Another thing, Diels-Alder reaction is between a diene, actually cis diene, it can undergo rotation to form this cis. And another thing, second point is that it's a electron rich diene, and in Diels-Alder it is essential to have electron rich diene and electron deficient dienophile. I'll explain this thing later. So okay, fine. Similarly this, and in presence of sulfuric acid 3 molar. Okay, so it produces this pinacolone. This is Pinacol, this is pinacolone. Okay, means it's a ketomethyl type group. Fine. So why I always write here distilled? Here also distilled. Why? Because there is a chance for production of other product. For example, one dehydration, then another alcohol, and we know alcohol's boiling point is very high due to hydrogen bonding. This is a very high boiling molecule, diol, glycols. So whatever, this alkene has not that much that type of weak interaction, so it's a volatile. So if we distill, it will be distilled out, so other product will remain in the reaction medium. So that's why we always write distill. So in distill means this is low boiling, it should be distilled out from the reaction mixture. Along with this, what can come? Along with this, here reaction, this produced this water, that may come, or maybe in case of sulfuric acid will not come, but some HBr may come if it is HBr. But that could be easily separated, because water HBr is miscible, but this alkene will not miscible. So separation is easier. That's why always it is written that distill. Okay, now we have obtained pinacolone. So now what is the reaction of this pinacolone? Just I suggest you look carefully about this pinacolone. This pinacolone is a very unique material. Why I am saying? Okay, and another thing I just erased. Major, here I have written one is our minor product is pinacolone. This, why minor product pinacolone is there? HBr mediated transdiene is major, but minor means the mechanism which this pinacolone form, that is also possible in case of HBr. That's why pinacolone is minor product there. Okay. So let's discuss about the reactivity of this Pinacol. I suggest you student, please look at this very carefully. It is very important for your exam, such type of transformation. So what type of functional groups are there? First is the tertiary butyl and another is the ketomethyl. So first equation, when we have ketomethyl, we see haloform reaction. Haloform reaction means in presence of bromine. In presence of means halogen, for example, bromine and alkali. So or chlorine, you can iodine. If you take bromine, then bromoform. If say chlorine, it's chloroform. It's iodine, it's iodoform. So what it produces? It produces carboxylic acid plus corresponding CHBr3. Since I have taken Br here, so this is one of the important reaction, that is haloform reaction. So this is haloform reaction to produce this carboxylic acid. Fine. So when this is carboxylic acid, so it can react with many things. Okay, before going to that, let's see about this. What other thing we can do? We can reduce this again using lithium aluminium hydride. So and second is H3O plus. Never forget to mention H3O plus. So what it produces? So this secondary alcohol will be reduced to corresponding alcohol. Second carbonyl will be secondary alcohol. So this is a secondary alcohol. Fine. So another thing, as I told, it produces acid in turn. This lithium aluminum hydride can also reduce the acid. So what it will be produced? So it will produce another secondary alcohol. Means here CH2. So see, after transformation, what can we prepare? Here this is neopentyl alcohol. Okay. So fine. Now another thing, what can happen? We can react this with thionyl chloride. So what is the advantage of reacting with thionyl chloride? Because of thionyl chloride react with acid chloride to produce sulfur dioxide plus HCl plus this acid chloride. Okay, so this is acid chloride. This is a recapitulation. So look at carefully. This is acid chloride. So what acid chloride can do? Acid chloride, we know that it's a very reactive reagent. Why I am saying reactive? Because it is electron deficient. This is another withdrawing effect. This is withdrawing effect. Both chlorine and oxygen. That's why it's very electron efficient. So what happens? So let's write it in this way to manage the space. So first it react with diazomethane in ether. So what it will produce? First diazoketone. After that silver plus water. So what is this reaction? This is Arndt-Istad reaction. I have made a dedicated video. Please see that video about Arndt-Istad reaction and the ketene to this final carboxylic acid, that is called Wolff-Rayet element. I have already made dedicated video with the example. Please look at this. It will be helpful for you. So what happened? This react with diazomethane and this to produce one unit higher homologue of carboxylic acid. Okay. So this is OH, this is CH2, and this is the one unit carbon chain elevation. For your recapitulation, I am telling, please keep it in mind that this CH2 is coming from this diazomethane. Okay, fine. So what another reaction possible? So this is acid chloride in presence of liquid ammonia. What it will produce? It will produce corresponding acid amine. Because it's electron deficient, ammonia will attack here, and another thing HCl will eliminate to produce acid amine. So this is tertiary butyl as carboxylic acid, or you can say trimethyl acetic acid, acid amide. Fine. So this can prepare many products. So whatever thing, let's write one. For example, this is 1, this is 2, this is 3. 3 reagent will produce 3 different things. So let's write it here. So if one reacts P2O5 means simple dehydration, means from here water will be eliminated, we know, and you can see there is 2 hydrogen and there is 1 oxygen, so 1 water removes. So if this water removes, then what will remain? This carbon and nitrogen, and actually it will form a triple bond. So it produces ultimately C triple bond N. This is nitrile alkyl nitrile. So in this way tertiary butyl nitrile would be prepared. This is 1. So if we consider these two are lithium aluminum hydride, and we know lithium aluminum hydride reduced amide into corresponding primary amine. I have made one video in the channel, please go through this, it will be helpful. So it will produce this primary amine. Why I am telling primary? Because this carbonyl is reduced to this corresponding methylene, and it is attached to one carbon, that's why it is primary amine. Okay, fine. Another thing, sodium hydroxide and bromine. This is Hofmann degradation reaction. Please keep it in mind. So what will be? It will result if these three will result this tertiary butyl amine. It is a very important, as well as getting tertiary butyl amine is also a difficult one. So in this way it will produce tertiary butyl amine. So it's a actually it's a primary amine, but it is tertiary butyl group attached amine. Okay, fine. So then this reaction possible. Another thing, this Pinacol could be transformed into other product. For example, if you see this first one, PCl5 ether. So what it produces? PCl5, this double bond is converted, this double bond O is converted into Cl, means this is Cl, 1Cl, this is 1Cl, this is CH3, fine. This is, so step 1 produces this. After that you see step 2. So what happened? In presence of sodium amide mineral oil. So here you can see 3 hydrogen is there. So these in presence of, since sodium amide is a very strong base, so in presence of this hydrohalogenation will happen. What happened? First of all, one proton will be abstracted by this NH2, and these will push and one chloride will remove. So what it will result? So this is Cl. So this is, in second step, another NH2 will attack, and sodium hydride is a very strong base, that's why it can abstract this proton also. This, and it will push and it will go. This step is difficult, but due to the extreme reactivity of this sodium amide, this is possible. So now what happens? It produces this CH. But one thing remember, never do the mistake. This acetylenic CH is more acidic. That's why under this reaction condition, it will undergo further deprotonation to produce this C minus Na plus sodium salt of this acetylide. Okay, terminal acetylene reacts with amide to form this acetylide. And after this H3O plus means protonation, it will be protonated to form this acetylene. So I have discussed many of this transformation using different reagent. It will be very useful. Do practice. Some questions similar type of using similar reagent you may expect in the exam. So finally, this is the end of this discussion. So in subsequent video, I will discuss about the Pinacol rearrangement, many things, and for this higher classes, for example MSc, BSc or CSI NET thing, many examples related to Pinacol is essential. So let's stay in touch and try hard. I wish you all the best, and before leaving, thank you for listening my video. Please subscribe my channel Chemistry the Mystery of Molecule, and if you like my teaching, please give a like and share this video among your friends so that many people could be benefited from my effort. And finally, please press the bell icon to get the notification, and see you in my